Hello everyone, welcome back. This is Anu here. Let me create a capacity planning Excel sheet that I'm using in all the previous videos in the system design and capacity planning. I'm using specific prompt in LLM to generate that kind of Excel, and usually I used to create two files. One is an Excel sheet, another one is an HTML file. HTML file is an interactive file. There I can go and experiment those configurations, and I can change the values and visually see how the system design values are going to change based on my input. The same thing I can do in Excel sheet. Excel sheet is a little bit tricky, but in web UI, it's an HTML page. You can change accordingly. This is the prompt I'm using. I'm going to share this link in the video description. You can go ahead and see. This is a universal capacity planning and system design prompt. What are the things there and how we can use this prompt? I am going to show you. You can copy this full prompt block below and fill this. This bracketed sessions are there that we need to change here. System name. What are the things in bracket we need to change? Currently, I'm going to change. Not change. I'm going to take the value for a Uber system. Okay, in Uber system, these are values we need to fill up. Uber and daily average user. How much is the daily average user? I'm going to consider as 500 million. Whether it is a read heavy, write heavy, or mix. If you are not aware about, then you can consider about mix or okay, mixed in value. Then core user action per day. What is a core action? The user we can just write it down what this user is doing. uh, Anyhow, it is not a video platform, it's a ride share. We can give the description over there. Peak traffic multiplier, how much will be the top at the peak traffic, how much will be the multiplier value, so that if it is 100 user at normal, then it will be around 300 user at peak time. Then data retention, how long we need to retain the data, either 3 to 5 years. This is normally value. Geo distribution is whether you are planning for a global application or regional. If it is Uber kind of thing, it's a global application. Then deliverables. These are the deliverables. From here, we need to copy system prompt. This is a user prompt. You are an expert system architect and capacity planning engineer with a deep knowledge in distributed system, cloud infra, and backup and envelope estimation technique. And task: create a complete production grade capacity planning system design document for which system I am going to create it for the Uber system. And these are the examples which I have created earlier. So I just got there. Scale assumptions are daily average usage. These are the assumptions. The system will generate some assumption on top of this one. I have given the leverage for that. Deliverables is uh, two deliverable. Deliverable is interactive HTML dashboard widget, and the second deliverable is Excel capacity planning workbook. Two files it is going to generate. Okay. Let's go ahead and execute this with the value for the Uber. And these are the formulas and metrics: write RPS, read RPS, peak RPS, daily storage, storage compressed storage, storage with replication, annual storage, ingress bandwidth, CDN, offload origin bandwidth, DB shared count, cache working set, and Kafka partition, GPU count, infra. Even though if we give all those details, AI system is going to analyze which platform you are going to analyze. Based on that, it is going to change the glossary page. Glossary means it is going to give, if it is a YouTube, the glossary page will consider all the parameters which need to consider when doing the capacity planning. It is going to change accordingly. Okay, so these are the details. Is there symbol system build with the symbol? We don't need to copy this one. These are the previous one. Up to here, we need to copy, and we can give this prompt. Okay, this is the dashboard. It's a beautiful dashboard it has created. This either we can generate the Excel sheet from here. We have the option here. Otherwise, we can. This is for just for a learning purpose or experimenting. Suppose if you're changing this value, how it is going to affect the end calculations and all we can see. So here in the web, we can see the scale assumptions and inputs. Okay, here daily average users and ride booking action per user per day. I haven't given this information to the AI system. It is already generated. A read action per user per day map 30. Peak traffic multiplier is 3x is the peak traffic multiplier. Cache hit rate is 85%. Average trip per code is 5, and average GBS event size is around 64. GPS events 1. Active driver percentage, that is 10%. Replication factor is 3s. Data retention is 3 year. And these are few constant values. Monthly average usage is 300 million. Seconds per day is a constant value. Active drivers is 10 million. Average trip duration is 20 minutes. A compression ratio 60. Metadata overhead is 8%. Maximum shared size is 500 GB. Kafka partition throughput is 10K messages per second. I haven't given any of these details. It is by default the system will generate this report like that. Then traffic request per second, how it is calculating traffic request per second. The formula is given here. And finally, to create the total RPA request per second. Then storage, it is calculating the storage, and bandwidth, it will calculate all the bandwidth requirement details. Infra requirement is calculating. Cost, it is calculating how much cost for compute, database, storage, bandwidth, content delivery network, Kafka, Redis, GP and all. Then growth wise, this is the 3x, 5x, and 10x. Suppose if it is a 1x is a baseline, if I have the 3x growth of a sudden spike, then this will be the requirement. This will be the cost, and if it is a 5x, this will be the cost. 10x, this will be the end projection. Architecture, this is a 7 to 8 layer architecture. Initially, it's a client layer. Architecture is better to show in another architecture design with a detailed description. These are the pipeline. User request, it will go to the authentication and element, then go to the geo lookup and driver matching. It will think about the search pricing. Then trip creation. Once it is created, it will be notified both then to the driver and to the end user. Notification will be sent, then it will give the GP streaming, that live data location, live location of that user. And once the trip is completed, then the payment settlement will happen. These are the pipeline walkthrough. Let's go ahead and see this 7-layer architecture. A writer application, it can be iOS, Android, or any other device. Driver have its own application there. You have web application, or it can be Uber Drive or Uber Eats. It will be going to the CloudFront content delivery network. Then it will go to the web application firewall and DDoS shield. Then it will go to the API gateway, authentication service, and TLS termination. Once it's processed there, if you see few values are here given, and few are corrected here. Why? Because A has given some values. When I looked into those values, few of them are mistaken. So those values has been corrected here. A has given 50. A has given this value. A 50 as this dispatch value, but the required server is 300 to 450 servers. CPU bound machine learning requirement. But also for the Kafka, A has given us 40 Mbps, but our requirement and calculations is far beyond that. 1 to 16,000 Mbps internal, 3x replication, and 4 consumers corrected from the A is given only 40 Mbps. That is the wrong value. That's why we said. That's why I said we cannot blindly believe AI system what it is generating. Always we need to go back before presenting or before presenting to someone. We need to cross check the value. We need to do the calculation by ourselves. We need to do the calculation by ourselves before sending to anyone or before presenting to anyone. These are the corrective values. AI has given 90 terabyte as the story, but we need a 2.1 terabyte per year. And that is for the database layer. From the Kafka, it will be different consumers are there: PostgreSQL, Cassandra, Redis cluster, or ST Glacier for the backup storage. Once it is done, it will go into this S3 geospatial, that's hex grid matching. Hex grid matching means this Uber services and all running on a hex grid pattern. It will be hexagonal shape location mapping it is using. Based on that, if that particular driver is coming into that hexagonal pattern near to the user, then that request will be sending to that particular driver and will be notified. That is a hex geospatial. ETA prediction, this XGBoost and deep reinforcement learning it is using. Fraud detection, real-time scoring. These are the 7-layer architecture of Uber system which we have developed. Let's go ahead and see the Excel sheet it has created. Uber capacity plan. Either we can use this Excel sheet it is already created by the LLM system as we have given the prompt, or if you are using this VBA here, we have an option to export to Excel. If you are satisfied with these values and if you calculated all these values, it is correct, then directly we can export it from there. I have given two options. Okay, converter. Two options. One is to create directly the VBA. From the VBA, we can do the export. Otherwise, we can directly go ahead and create that Excel sheet. Either of the option, you don't need to give both. Either of the option we can see. If you want to visually create all these things and you don't need to worry about the Excel equations and all, then use this VBA and finally you can export to Excel. Finally, you can export to Excel sheet. Let's see the exported value as well as the one which created by the LLM. Okay, this is not that much fancy as look like the other one which is created, but we have all the values available here which is already seen from the VBA. We need to reformat it a little bit. Bandwidth. If you see, there won't be any glossary kind of thing, and infra requirement, cost estimation, everything is separated. If you see, compare with the other one, but here it is giving the glossary, capacity plan and readme. Capacity plan will include all the one after the other instead of different sessions. This is the pipeline, and this is the glossary will consider all the parameters which need to consider while doing any capacity planning for Uber kind of system. It is considering around 32 different terms it is considering to do this capacity planning. I just given this payment system that we already seen, not the payment system, it's a pipeline, and it is a capacity planning how it is done for this 100 million users. This is a readme, what are the parameters it's considered. These are the parameters it's considered for doing this capacity planning. This is how I am doing this capacity planning, and whenever we do this capacity planning using AI system, don't blindly believe it. We need to, these are the equations or notes. We need to go to the glossary tab and see the equations, how it is calculated, and do the calculation manually before presenting to someone. Then see whether these equations are matching or not. Instead of this value, you can ask the LLM to create one more column saying that it's a human readable value, so that this will be converted. It will be during the presentation, it will be very difficult to read. It is around 100 million or something like that. 100 million. It will be difficult to read at that time. If you ask the LLM to create a human readable value column, it will create one more column called human readable value. It will be easy to present. This is all about this leveraging of AI for doing the capacity planning. This is all about how we can use this kind of system design template and leverage its power. And I'm going to attach all these details in the GitHub repo, and I will share that GitHub repo link in the description section of the video. And you can use those template, or you can use this prompt to create a new template for any kind of system. Thanks for watching this video. Have a good day. Bye.